Assalamualaikum and hello. Let's continue with the reactions of alcohols where we are going to learn a lot of chemical properties in this video. I'm going to focus one by one. Basically for the introduction first, in order for you to learn the reaction of alcohols, we are going to involve two bond cleavage. The first one is between O and H bond, and the second one is between carbon and OH bond. So for OH bond cleavage, we are going to use reaction with group 1 and group 2 metals, oxidation, and esterification. For the reaction involves COH bond cleavage, we are going to focus about dehydration only. For substitution, this is for your next syllabus in PST. Alright, let's continue with the first reaction, which is reaction with group 1 and group 2 metals. For your information, alcohol reacts as a very weak acid in aqueous solution. So as you see here, the reaction between alcohols with metal, I take one metal, sodium metal, this is from group 1, reacts with alcohol under condition hot, you will get the products just like this one. So how the reaction happen? For your information, the bond cleavage is between atom oxygen and hydrogen in alcohols. And your metal here, there is no charge yet because this is a solid metal. And what's next? I'm going to do the bond cleavage, which is specifically for heterolytic cleavage. From here, I'm going to give the electrons from this bond to the most electronegative atom, which is oxygen. So as you see here, oxygen is more electronegative than hydrogen. So both electrons from this bond is going to be transferred to oxygen atom. That makes oxygen as O- here. And what's next? You got sodium, which is, in order for it to achieve the stability, it will donate one electron so that the charge will be Na plus for the ion itself. So right now, Na plus will be attracted to the negative charge for O minus. So that's why we are going to write it down as close to one another, RO minus Na plus. R here is depending on the alkyl groups in your question. And what's next? You got H plus here, the one that's left. It's going to react with another H plus from another alcohols, the same one, to make as H2. And what's next? We are going to balance your reaction based on both sides. You can see that all of this here already balanced for alkyl, oxygen atom, and sodium atom. But right now, the one that is not balanced yet is we got one hydrogen here and two hydrogen here. That's why I put coefficient half in front of chemical formula hydrogen gas. And please make sure you need to indicate hydrogen gas as gas, or you want to write it down as an arrow towards up. Both of these are acceptable. So that is the general equation for reaction of group 1 and group 2 metals. Let's try example 7. So here I got my reaction. The alcohols, my ethanol, reacts with sodium. So what will happen here, we are going to do the heterolytic cleavage. My bond breaking is going to break here. And what's next? I'm going to copy back my structure as it is without hydrogen. So I will have this structure as my product with O minus, and then you have to understand as before, O minus will attract or pull Na plus from Na metal. So I will have Na plus close together to O minus. And next one, I'm going to add up my side product, which is hydrogen. And hydrogen here is in gas phase. But you have to make sure your equation is balanced. That's why I'm going to put coefficient 1/2 in front of it. So this is the balanced chemical equation for the reaction of alcohols with group 1 metal. Now let's continue with group 2 metal. For group 2 metal, we are going to do the bond breaking or bond cleavage around this part. So what's next? I'm going to copy back my structure, which is this cyclic ring attached to O-. And next one, you got magnesium. So for magnesium, in order for it to achieve its stability, magnesium is going to donate 2 electrons. That's why the charge will be Mg2+. So this reaction will connect with Mg2+. And what's next? You can see that the charge cannot be cancelled here because this is -1, this is +2. It's different case with this one, -1 and +1, you can get the neutral. But right now, it is not neutral yet. So how you want to solve this problem? So I'm going to put bracket here to indicate 2 of this cyclic connect to O-. And that's why we got this structure as your major product, and don't forget your side product, which is H2 gas. But right now I'm going to indicate by using arrow towards up. So from here you can see that I'm going to make it balanced. So you can understand we got 2 hydrogen here but 1 here. We got 1 magnesium, and we got 2 for this structure. So it means that I'm going to balance this one by putting 2 in front of this structure. So I'm going to put coefficient 2 in front of it. So that's why your equation is balanced for this case. So that's all for this reaction. Next one, we go to the second reaction, which is esterification. For esterification, the reagents involved is between alcohols and carboxylic acid. So for alcohols, we are going to make the bond cleavage here, and for carboxylic acid, we are going to make the bond cleavage here. So what will happen? Hydrogen from alcohol and OH group from carboxylic acid will combine together to form water, and the rest of the molecules will combine together to form ester. So this is under reflux with catalyzed mineral acid. For example, we usually use HCl or H2SO4. Your alkyl group R1 and R2 can be same or different, but make sure you can identify which one is alcohol, which one is carboxylic acid. For example, I got methanol. So methanol, the bond cleavage will happen here between O and H atom, and for ethanoic acid, it will happen here. So I'm going to combine everything under mineral acid and reflux. I will form my ester, where it is the combination from this part and this part, and my water is from H of methanol, OH of ethanoic acid. So that is general one. So let's continue with one example. So I got this structure. How am I going to draw my equation where I got this is my alcohols with OH group attached to it, and I got my carboxylic acid with carboxyl group attached to it. I hope you still remember. So this is my alcohol and this is my carboxylic acid. So the bond cleavage for alcohol will happen here, and bond cleavage for carboxylic acid will happen here. So I'm going to combine H from alcohol and OH from carboxylic acid. So I will form H2O as my final product. So the rest of it combine together to form ester. So I'm going to draw my structure one by one, starting from alcohol. So I got C bonded to CH3, 3 of them. And the next one I bonded to CH2 attached to O. And then this O is coming from here. It's bonded to carbon for carboxylic acid. So I'm going to straightaway draw C double bond O, and then this one attached to CH2, and this carbon attached to the cyclic ring. So this is the structure for my ester. And don't forget the last one, my side product is plus H2O. And this H2O is coming from the combination of hydrogen and OH. So this is how you want to draw the structure for ester based on this example. Now let's go to oxidation. For oxidation, it is compulsory to use oxidizing agent. So I'm going to introduce to you the strong oxidizing agent that will be used when you want to do the oxidation. Usually we can use acidified potassium permanganate in acidic condition, and the condition is hot. So how you want to write it down, the reagent is acidified KMnO4, or you can write it down as the chemical formula KMnO4, H+. H+ to indicate acidified word. And the next one, the condition is hot. So you can also replace KMnO4 with potassium dichromate or sodium dichromate. But here I'm going to show by using one oxidizing agent. First, we got a few different alcohol that we want to test whether they can undergo oxidation or not. Let's go with methanol first. Methanol is CH3 bonded to OH group. So you can see that when I want to write down the equation, I'm going to put plus KMnO4. On the top, the arrow is H+. Bottom one is the heat, or you can put as triangle. And what is my product? The product will be carbon dioxide plus H2O. So methanol can undergo oxidation due to this carbon that has OH group contains hydrogen atom. So hydrogen atom here can be reduced to form carbon dioxide and H2O. That's why methanol can show observation where purple color solution turn colorless. This purple color is to indicate the color of potassium permanganate here. Next one, I got primary alcohol where my carbon, this one, attached to OH group, and this carbon as well got one alkyl group, two hydrogen atoms, and reacts with acidified potassium permanganate in acidic condition, you will form carboxylic acid plus H2O. So H2O, it is compulsory to write it down as your side product. So primary alcohol forms carboxylic acid in oxidation. And your observation, same as methanol. Purple color solution turn colorless because we use the same reagent, acidified potassium permanganate. Next one, I got secondary alcohol with carbon that has OH group attached to two alkyl groups and one hydrogen atom. So for secondary alcohol, you still got the reducing hydrogen, one of it, and reacts with KMnO4 with H+ and heat, you will form ketone plus H2O. So the observation still the same, purple color solution turn colorless. I want you to understand here, if you use dichromate, Cr2O7 2-, you can observe the color changes from orange solution into green color. So it depends on you. Usually I will always use potassium permanganate because it's much more common for you. The last one, we got tertiary alcohol. In this case, I got my carbon attached to OH group, and this carbon attached to another 3 alkyl groups. So from here, you can see that there is no reducing hydrogen. So of course, when you want to write the equation for oxidation of tertiary alcohol, at the product side, you have to write it down no observable changes because tertiary alcohol cannot be oxidized. This is due to no presence of reducing hydrogen. And for the observation, the purple color solution remain. So these all are the oxidation reaction for alcohols based on different classes, primary, secondary, and tertiary alcohols. Next one, I can also use my oxidizing agent, which is PCC in dichloromethane. PCC is what we call as pyridinium chlorochromate. That is a long name, but we can make it short in your equation as capital letters PCC. So if you got primary alcohol and secondary alcohol, because only these two classes of alcohol can form products when do the oxidation by using PCC. So if I got primary alcohol reacts with PCC, on the top of the arrow is dichloromethane, I can form aldehyde. So please make sure here is aldehyde, not carboxylic acid, because when you use strong oxidizing agent, you can form carboxylic acid from primary alcohol. But the difference here, when you use PCC, your mild oxidizing agent, you will form aldehyde. And the next one, for secondary alcohol, reacts with PCC in CH2Cl2, you will form ketone. Same goes for strong oxidizing agent. So the difference only for the primary alcohol sahaja. So for your information, PCC is very exclusive, only can be used to convert primary alcohol to aldehyde, and it stops there. It cannot continue to form carboxylic acid because it is just a mild oxidizing agent. Next reaction is dehydration of alcohols. So this is name of reaction. I hope you still remember if I ask you for Chapter 3 alkenes, where name of reaction is dehydration of alcohol, and the type of reaction is where we are going to eliminate water as my side product. So the type of reaction will be elimination. So here I got alcohols as my reactants, and I can see that the carbon involved is between first carbon that holds OH group and the second carbon that got adjacent hydrogen atoms. So we are going to eliminate OH from the first carbon and hydrogen from second carbon with concentrated H2SO4 and heat as my reagents and conditions. I will form multiple bonds, which is double bond between carbon 1 and carbon 2, and these two will combine together to form water as my side product. So this is just the same as the previous chapter 3. So I hope all of you are clear about reactions of alcohols. There are 4 of them. The first one is reaction with group 1 and group 2 metals. The second one is esterification. The third one is oxidation. And the last one is dehydration of alcohol. That's all for this video. I'll see you in the next one. Bye!